So this video is going to be very similar to our last one on sine, but we're going to be using cosine instead. So let's draw in an angle of 55 degrees. What would the cosine value be? You think it's going to be positive or negative? And this is one of those reasons why coming to class and engaging in some class conversation could be helpful, because we're talking about things like, remember our hypotenuse is 1, and remember from geometry that this would be your adjacent side from our 55 degrees, and then over here would be our friend the opposite side, which we knew was sine from our last video. So context clues, you guys are pretty smart people. We can kind of figure out that cosine of 55 is going to be our adjacent side over our hypotenuse. And if you think about what that value would be for our adjacent side right here, it's going to be positive because we are in the positive x's. Down here would be our negative x's, but for 55, it's positive. So that's why it's positive. In what quadrant would another angled measure have the same value as cosine of 55? Okay, so thinking back to sine, if we think about sine for a minute, we went over here because over here was a positive y value, and that worked for sine. However, we're not talking about the y-axis anymore. Now we are talking about x. And in order to get another value, another angle measure that has that same x value, we're going to have to go down here. And sorry I wrote that other one in there, but this angle here would be 55 degrees. So we drew in that second triangle. What is the angle of that second triangle? So this is where we can just start back at the x-axis, oops, and loop all the way around. Woo! So that would almost make a full revolution of 360 degrees, but we are stopping 55 degrees short. So the polar angle would be the 305 degrees to get to that 55 degree reference angle that has the same value as the cosine of 55. So if you would like to check that, you should be able to take the cosine of 55, and it will be the same thing as the cosine of 305, because both of those triangles have the reference angle of 55, and they share this adjacent side, which is our x value. We can make a couple of assumptions from that. We know that x values are positive in quadrants 1 and 4. So if you have a triangle there, and you have a polar angle, I should say, both of those are going to have a positive x value. Positive x. Now that's very similar to the other quadrant, but if we go backwards, think about what happens to our x. Our x value here is negative. So we have a negative x value when we go back in the unit circle, back in that coordinate plane. So these two quadrants will have negative x values, so these will be the cosine of theta will be negative, where over here the cosine of theta will be positive. Now let's do a couple of examples meshing together both cosine and sine within some examples. So cosine of 150, starting there. 150. If here's 0, here's 90, here's 180, we know that 150 lies over there in the second quadrant. Every time we have one of these angle measures, we are going to drop a perpendicular line straight down to the x-axis, and that will give us our reference angle that we can use for this triangle. So if that's 150 degrees, and we know that a half a circle is 180, we know that within that triangle we have a 30-degree measure, because 180 minus the 150, that leaves 30 degrees. So the question is, sorry, we made that, we got the reference angle. Draw a second triangle with the same sine or cosine of the given triangle. Since we know that cosine is our x value, we need to draw another triangle that has that same x value. So I'm going to draw it down here. So it's almost like you're drawing the same triangle, but it's in a slightly different location. So this also has a 30-degree reference angle. So list the angle for both triangles. Well, we have cosine of the 150. And then what would it be if we looped through it to that other point right here? Now that would be 180 plus the 30 degrees we're talking about in that reference angle, and that will be a 210 degree angle. So using your calculator, the cosine of 150 should be equal to the cosine of 210, because we know that the x values of both of those reference angles, or polar angles, will be equal. For today, hopefully you got 0.866. Moving forward in this unit, or if you watch this video later, we will be strictly using square roots and fractions, but for today we're going to stick with those silly old decimals. Okay, so again, what value, what degree measure will be equivalent? The sine of 210 is equal to the sine of what other degree measure? So let's go through that same process. We're going to draw 210, which we just kind of talked about was over here somewhere, 210 degrees, and then we need our reference angle for that. So if this is 180 degrees, how much more did it take to get to the 210? Drop this line straight down to that x-axis to get our right angle. So from 180 to 210 is a 30 degree angle. And now it's sine. So I'm going to put a big Y reminder right there that we are talking about our Y. And in particular, we are going down. So this is going to be a negative Y. And in my brain, I kind of think about, yep, over here, I also have a negative Y value. And that will help us to determine our other angle measure, because it's going to be another location on this coordinate plane that has a reference angle of 30. Oh my gosh, it all deleted again. So our question being, if we want that angle to be 30 degrees as well, what is this angle to right there? So that's going to be our 360 degrees, because it's almost a full revolution, but not quite. We're not going to get that last 30 degrees. So this is a 330 degree angle. So if you could check it quick, the sine of 210 is equal to the sine of 330. And I believe it should be negative 0.5. Again, cosine of 340 is going to be equal to the cosine of what other angle measure? What other angle measure on this coordinate plane has the same cosine value or the same x value? So 340 is going to be over here. Because you loop all the way around, this would be 360, but it sounds like we are 20 degrees shy of that value. So if this is 340 degrees, drop that perpendicular down. Cosine is x. So now I got to think to myself, what other triangle on this coordinate plane has the same x value? I'm like, well, x kind of is easier to me in my brain because you don't have to draw a whole nother triangle. It's just kind of right there. So you're going to use that same x value that has a reference angle of 20 degrees, and then you have to come up with what that degree measure is. So 20 degrees is the reference angle. How many degrees did it take to get up? Technically, I suppose there's a couple different answers. You could just say the 20 degrees. You could say, oh, well, I went an entire revolution and another 20 degrees. And you could say 380 degrees, but to be specific, we're probably not going to go over 360 much. It's going to be most proper to just stick to the 20 degrees. So check in your calculator. Cosine of 340 is equal to cosine of 20. Thanks for listening today, guys. Sorry about some of those technical glitches. We will keep learning. Thank you.